So the first section on the test is going to be simplifying polynomials and listing all excluded values. So just a reminder of do not divide anything out whatsoever until you've excluded all the values. So on like number 1 here, once again, before we do anything, exclude the values. So that's when the bottom equals 0. So you would say A cannot equal 0, correct? And you should sit over here so I'm not blocking your view. I don't have to turn very much. And then B cannot equal 0 as well. Any questions on that part? Okay, because that would be 20 times 0, and then times 0 if B was 0. Okay, so now we'll simplify it in sections. So 15 over 20, they both divide by 5, correct? Or if you have a calculator, you can just do 15 divided by 20, math, enter. So this is 3 over 4. All right, and then 8 to the 4th over 8 to the 5th, it's just A, correct? When you divide, you subtract, your exponents always top from bottom. There's 5 A's on bottom, 4 A's on top. So make sure when you divide those out, that's an A on bottom. Put it in the correct spot. B to the 6th on top, B to the 3rd on bottom. So when you divide, you subtract, correct? So it'll be B to the 3rd on top. And so that would be our answer would be, right, 3 B to the 3rd over 4A. And that was it, as long as A does not equal 0 and B does not equal 0. That would be our first answer. So really that one you guys should not miss. It's the easiest one on the test, I'd say. Okay, so number 2, different kind of simplification. Remember, we don't divide things out in sections. If there's an addition or subtraction sign, you've got to have it factored out. So we'll factor out the top very quickly here. What multiplies to be -3 and adds up to be -2, 1 times 3, -3. So the top, I'm going to rewrite the whole problem, is x plus 1, x minus 3. On bottom, we're factoring it. What multiplies to be -6 and adds up to be -1, 3 times 2, -3. So we have x minus 3 and x plus 2. Factor these correctly. So once again, please restrict your domain. Like, don't miss all the easy stuff. Like, the restrictions should be the easiest part. Make sure you restrict the domain before you divide anything out. So x cannot equal 3, x cannot equal -2. Make sure you don't mess those up. Like, if you need to go off to the side and actually set them equal to 0 and solve, do. Is everybody good with that? Okay, so then we can now divide out exact values. So those divide out to become 1s. So that's it. So x plus 1 over x plus 2 is our answer, as long as x does not equal 3 and x does not equal -2. So that one will be pretty easy as well. Okay, next one, number 3. Same thing. Like I said, this is the same order and everything. Same type of stuff. Number 3, it's simplify and state the excluded values. So once again, this is not factored out. We would never divide out in sections. We have to have it all factored out. So on top, the first thing we should be noticing up here is there's an x in common, only an x. So we're going to factor this out by pulling out an x. So I'm just focusing up here. We're pulling out x, left is 4x squared plus 3x minus 1. Make sure you don't stop here. If it continues to factor, you need to keep going. So it multiplies to be a times b. Do not quick factor on accident on something that you can't. 1 multiplies to be -4 and adds up to be 3. 1 times 4, -1. Then we have to drop and break. 4x squared minus 1 plus 4x minus 1x. Group these two, group these two. So we'll pull out 4x, right? We all know how to factor. Like, I don't need to go very slow over this part, right? Like, okay. So we'll pull out a 4x. Left is x plus 1, plus 1. Pull out a -1 right here. Left is x plus 1. So our safe haven's the same, so we know it did continue to factor. We pull out x plus 1, and left is 4x minus 1. Now, do not forget that you originally factored out an x. That's one of the most missed things on the test, is people will forget that they originally factored out that x. Okay, so that's on top. Now on bottom, I want you to notice something, okay? You should always be watching for this. Doesn't a 4, even though there's not an x in common, wouldn't it be nice to factor out a 4 first, because then we can quick factor it? So don't long factor something like this, because it does pull out a 4. So then if you pull out a 4, left would be x squared minus x minus 2. So then that quick factor is what multiplies to be negative 2 and adds up to be negative 1. 1 times 2, no, positive 1 and negative 2. So we pulled out a 4, and then we quick factored our x plus 1 and our x minus 2. Do not forget, though, that you originally factored out a 4. Like those little things are what fail people on the test. When I said most people fail the test, like a lot of people fail this test, it's because of little things like that. Okay, restrict your domain first. 4 is never going to be 0, so there's no variable there. So x cannot equal negative 1, x cannot equal 2, correct? Now we can divide out. X on top, nothing on bottom. So that stays x plus 1, x plus 1. They divide out to become 1, and that's it. So left was x times 1 times that. So you'll have 4x minus 1 in parentheses times x. You don't have to distribute your final answer, so you could just leave it. And what if you distributed wrong and missed it? And then we have our 4 and our x minus 2. That is our answer as long as x does not equal negative 1 or x does not equal 2. So that's the first part of the test, but really that should be the easiest part of the test if you don't make little errors and do like careless things. Okay, number 4 on the test will say, is something like, so is this okay? So if this is our original problem in black, can I divide out with 3x squared and not 3x? No, right? We know that's a huge no because of the plus sign, correct? We only can divide out multiplication. So that's what you would say, you know? Like, we know this is absolutely not okay because we only can divide out exact factors. It's connected with an addition sign. And then you could correct it. So on top, shouldn't we have factored out a 3x first? And then left would have been x plus 3, correct? And now on bottom, oh, yeah. And then on bottom, we have 3x. So now it would be okay, but that's a way different answer than mine x over, yeah, whatever that would be. Does everybody understand? Okay. So next section of the test will be a problem similar to this. You've got to be able to do this kind of problem, but it's just a little bit not too bad, right? So a rectangular prism has a height that is 2 more than 3 times the width. What is the length of the prism if the volume is this? So the first thing I start out with, it says a rectangular prism has a height that is 2 more than 3 times the width. So first of all, we know something about the height, but I'm going to come back to that. It said something about width, but we don't know what width is, so let's call it x. So then it says the height is 2 more than 3 times the width. 3 times x would be 3 times the width, and then 2 more than that would be plus 2. Wording, does everybody get the wording on that? So now think about it. It says, what is the length? So length equals, we don't know. What's the length if the volume's this? So then you should say to yourself, okay, I have all this stuff I need to be able to solve, but you can't solve without an equation. So what's our true statement? Volume of a prism, a rectangular prism, is length times width times height. Put in what you know. This is your volume, so we have 3x cubed minus x squared minus 2x equals our length, which is question mark, times our width, which is x, times our height, which is 3x plus 2. Then remember what your goal is. It says solve for the length. So we need to get question mark alone. What undoes multiplication? Division. Divide by x, 3x plus 2 to both sides. And then remember, those divide out. So now question marks alone. So that is our answer. But then you just say to yourself, okay, that is my answer, but does my answer simplify? Well, yes, it does. We factor out the top. So on top, we're factoring out an x. Left is 3x squared minus x minus 2. And then we'll keep factoring that. It's long factoring. There's going to be quite a bit of that. We'll multiply to be negative 6, adds up to be negative 1. 3 times 2. Negative 1? Yeah, negative 3 and 2, right? So very quickly here, drop and break, drop. So we have 3x squared minus 3x plus 2x minus 2. Factor out of 3x. Left will be x minus 1. Factor out of 2. Left is x minus 1. So the top factor to be x. 3x plus 2. And x minus 1, okay? And then on bottom, we had x and 3x plus 2. And that was equal to question mark. So now we can divide out exact factors. We don't need to restrict for this one, right? We're just solving for question marks, so we're done. X minus 1. Any questions on that one? Okay. Okay, so then the next section will be multiply and divide the rationals. Remember with these, you do not need a common denominator. If you get one, you're going to get it wrong. Multiply and divide the rationals, state excluded values. That's the most important thing with these, is stating the excluded values, because those are the easy points that people miss. So before you do anything with these, look at your denominators, have them all your denominators and stuff factored out, and state your exclusions. 2 will never be 0. X cubed, well, if that, to be 0, that would have to be x equals 0, correct? So that's our only excluded value. Any questions on that? Now remember, we can multiply straight across. However, we would not want to multiply this all together and then have to refactor it. Leave it all factored. Does that make sense, everybody? So basically with multiplication, you're extending the line here, and now just divide things out that you can. So, and make sure you divide out everything that you can. So x3 doesn't divide with anything on bottom. X squared divides with x cubed, right? To be x on bottom. 8, does it divide with anything on bottom? 2. That would be 4. Make sure you do it in the correct place, because if the 2 is up here, the 8 was down here, it doesn't just become 2 on top. 4 over 1. Okay. Now you have to make sure, because what happens is sometimes, like let's say that this didn't become a 1. Let's say this became a 2. Like those would, or like let's say, I don't know, it became a 6, then 3 and 6 would have divided. So you just got to make sure it all divides out. Like nothing on top divides with anything on bottom. So now we've divided everything. So now we will multiply what's left. Remember, these are just ones, guys. 3 times 1 times 1 times 4. 12 is on top. On bottom, we had 1 times x, which is just x. Did I miss anything? I don't think so. X cannot equal 0. Okay, next one. Multiply this. So remember, we're going to first factor out everything. So this is really 3 over, what should we factor out first? A 2. Then we have x squared minus 1, correct? Still not done. That factors right again. So we have 3 over 2. What multiplies to be negative 1 adds up to be 0. Plus 1, negative 1. Is that too fast? I feel like we're all pretty good at that at this point. So we have x plus 1 and x minus 1. And then we have times. Let's quickly factor this. Now, once again, let's be smart about this. Would I want to long factor it? Yeah, it'll work, but couldn't I factor out a 4 first? Let's do that. Factor out a 4, divide by 4, divide by 4, divide by 4. So that's x squared plus 2x minus 3. So then you say, does that factor more? Well, yes. Multiplies to be negative 3 and adds up to be 2. 1 times 3, negative 1. Okay, rewriting this again. And once again, really, if you show your work and not get your work messy, you're going to make less errors. So it's like it's taking me an extra 5 seconds to rewrite this. So we have 4, x minus 1, and then x plus 3. Now remember, guys, this is on top, technically, so divided by 1, correct? Okay, so now let's restrict values before we divide anything out. That's always got to be, if you are restricting values before you do anything, restrict them. 2 is never going to be 0, x plus 1, so x cannot equal negative 1, x minus 1, x cannot equal 1, and 1 is never going to be 0. So we have our 2 restrictions. So now remember, with multiplication, it's basically extending the line, correct? And dividing out exact factors. We have 3 on top, anything that divides with 3 on bottom, nope. 4 on top, anything that divides with 4 on bottom. So that'll be 2 on top, 1 on bottom. X minus 1 over x minus 1 is 1 over 1. X plus 3, x minus 1. Now, once again, make sure that anything left over, there's nothing that it divides with on bottom. 3 and 2, that's 6. 6 doesn't divide with anything on bottom. Okay, so let's multiply at least 3 times 2 back together. 3 times 2 times 1 is 6. And then we have x plus 3 left on top. And on bottom, we have 1 times x plus 1. That's our answer, as long as x does not equal negative 1 and x does not equal 1. So that was the next section. We'll just be that many and multiplying and there's more. So now divide these. It looks a lot more daunting than it actually is. So remember, dividing fractions is easy as pi. We flip the second and we multiply. So let's factor each piece. So what multiplies to be negative 2 adds up to be 1. 1 times 2. And really on the test to get through it, we've got to be about as quick as I am at factoring. So that's -1, right? So that red piece that I just put a star by factors to be x minus 1, x plus 2. Sweet. We won't divide anything out until we've restricted our domain. On bottom, we'll pull out a 2. Left is x plus 2. Everybody comfortable with that? And you'll say times. Make sure you draw your little arrows if you need to remember. So on top, we have 8x plus 56. Shouldn't we factor out an 8? Then x plus 7. Okay, now we'll do the bottom. Now, once again, you could long factor this, absolutely. You'll get it right, but then you'll have to make sure it's factored completely. Shouldn't we pull out a 2 first? So pull out a 2, left will be, I'm going to do it over here because then we'll have to factor it again. Pull out a 2, left is x squared plus 2x minus 3. Well, multiplies to be -3, adds up to be 2. 1 times 3, -1, right? We have a 2, don't forget the 2. And then we have x minus 1 and x plus 3. Okay, restrict your domain before you divide, not anything out. Okay, 2 will never be 0. X plus 2, so x cannot equal -2, correct? 2, never going to be 0. X cannot equal 1. X cannot equal -3. There's our restrictions. Now start dividing things out. X minus 1 on top, x minus 1 on bottom. 1 over 1, x plus 2, and x plus 2. Okay. 1 over 1, 8 on top, 2 on bottom. And 2 2's on bottom, right? So we could go about it like this. 8 over 2 is 4 over 1. Now 4 over 2 is 2 over 1. Okay, that's what I meant when I said make sure it all divides out. Okay, and then that's it. Left was 1 times 2, which is 2. We got our x plus 7. Just leave it all factored out. You don't need to distribute it, so why do extra work? 1 times 1 is x plus 3. As long as x does not equal those values. So I'm just going to go like this and circle those. That is the same difficulty level as the one on the test, so we can do that for sure. Okay, if you see it in this form, don't let it throw you off. That's the same thing, right? Dividing fractions easy as pi, flip the second and multiply. Okay, so the x minus 1 comes on top, x plus 2 on bottom, multiplying. This factors to be, what multiplies to be -2 and adds up to be 1. 1 times 2, -1, right? So we have x minus 1 on top divided by, or sorry, times x plus 2 divided by 4x times x minus 1 over x plus 2. So now we'll restrict the values first. X cannot be 0 and x cannot equal -2. Now we can divide things out. X plus 2, that's it, right? So we'll have left over x minus 1 times x minus 1. Just leave your answer all factored out. That's great. And then left on bottom was 4x. And then as long as x cannot equal 0 or -2. That is the same level you're going to see. Everybody good with that? We're going to all ace that. Sweet. Okay. So my question for you is, this fraction divided by this fraction the same as this fraction divided by this fraction? It's not the same. So let's make sure we can divide this correctly, because if you get that right and say no, that's only half credit. Showing your work correctly is the key. So this is really x divided by 3 divided by y over 1. I always draw my ones. So dividing fractions is easy as pi, flip the second and multiply. So our answer on top would be x over 3y. Correct? Over here, this is really x divided by 3 divided by y. Once again, I always write in my ones. Flip the second and multiply. So times by y over 3. So we get xy over 3. So then you would show your work correctly and say, so no. Not the same. Okay, next portion of the test will be adding and subtracting rationals. Probably the hardest part for people, but really they're not super advanced ones. You have to get a common denominator, not make mistakes with subtraction and stuff. Please do not miss these. So, common denominator. In this one, isn't my least common denominator 6x cubed? Can't we make 3 of 6? And then we can make x cubed. Does everybody see that? So this one, so our least common denominator is 6x cubed. Okay, so this already has that. We need to make this 6x cubed. So we need to multiply by 2 and x squared. So we're going to do that to the top. Make sure you don't, let me tell you what you need to not do. So other teachers were saying that at this point, their students were doing this. They were leaving it all factored. They were doing 1 plus 4 times 2 squared, and then they were just putting a fraction and then on bottom writing like 6x cubed, and then they were dividing out things in sections. We know that we can't divide out things in sections first of all, right? And we've got to combine all like terms on top before we divide anything out. So I'm going to do it differently so I make sure to not do that. So we really have this 1 over 6x cubed plus 8x squared on top, right? Over 6x cubed. So now that I have my common denominator, I've made sure by actually multiplying all this out, I say now I can combine my tops together. So that would be 1 plus 8x squared all over 6x cubed. Okay, so now that I've combined all like terms, and I really should probably put it in standard form, 8x squared plus 1 over 6x cubed. So now my question for you is, does that simplify? No, right? It doesn't. We can't divide things out in sections, correct? The plus sign, and that's a quadratic that does not factor. So we're good. Everybody understand? Don't do weird things. Okay. With this one, get a common denominator. Isn't it just going to be x, because x minus 1 is an entire factor and x plus 2 is an entire factor. So we've got to multiply this one by x plus 2 over x plus 2. This one by x minus 1 over x minus 1. One of the most missed problems on the test because it's a subtraction problem. Now do not do this. Watch, this is the better one to show you what students were doing in other teachers' classes, which you're not going to do. They were doing this. They were going like this. 2 times x plus 2 minus 3 times x minus 1 all over x minus 1 times x plus 2. Technically that is what we had, but then their students were going like this. Oh, look. Oh, that was literally just doing the exact opposite of what you just did. Do you all see that? Okay, so we would not do it like that. We would say, okay, I need to multiply this out and rewrite it. So we have 2, that was 2 and x plus 2. Okay, so we have 2x plus 4 right there, correct? Then multiply the negative in with 3. Negative 3 times x is negative 3x is right. Here's where people miss it. Negative 3 times negative 1 plus 3. Combine like terms, so don't even write the denominator until you've combined like terms. So that's negative x plus 4 plus 3, right? Are we all good? So plus 7. And now that was all over, the denominator still there with addition and subtraction. So all over x minus 1 and x plus 2. That answer would be acceptable. Oh, yeah. Yes, we could, with this one, it doesn't have you restrict the values. If it doesn't say it in the directions, don't do extra work. So we're good, okay? So anyways, and then on top, it would be acceptable to factor out a negative 1, left is x minus 7. I'll accept this answer, but this answer is really good too, because then I'm like, okay, they know to make sure that nothing divides out. Any questions? Okay, do not miss that one because it's not a bad one. Okay, get a common denominator. Should I just, well, I should not, okay, I'm just going to say I should not just say, I'm going to multiply by x squared plus x minus 2. I'm going to multiply by x plus 2. We want the least common denominator. To know, we've got to have this part factored out. So only the bottoms, because we're only trying to get the bottoms factored out, because on the top, we'll have to multiply it all back together. So x minus 1 and x plus 2, correct? Okay, so this one just means an x minus 1. We only had to fix one of them. So x minus 1 over x minus 1. Make sure you use parentheses anytime you have two terms. Now look at your denominators. They are the same. Do not write this over the same fraction until you've multiplied everything out. So we have x, and then we have plus 3x. Positive 3 times negative 1 is negative 3. Combine like terms. For x minus 3. That was all of the top combined. Now that's over x minus 1 and x plus 2. Everybody good with that? That's the level you're going to see, so it's very doable. Okay, subtraction is once again, one of the most missed problems on the test. Okay, look at these. Don't they already have a common denominator? Yeah. Okay, so we just need to make sure that that negative gets distributed through correctly here. So remember, now we can just combine like terms on top. 2x squared minus 1x squared. Positive 1x squared. Everybody good with that? Cross them out as you go. Don't cross out the negative though. That's really negative 2x, okay? And that's really positive 1. So now I'm going to ignore that minus sign. Did that bother anybody? Did that bother anybody? Okay. So now we can just combine like terms. I distributed the negative through and then wrote it as plus. Positive 3x plus negative 2x. Plus x, very good. So I've just done those. And then negative 3 plus 1. Negative 3 plus 1, good, is negative 2. Okay, good. So that's all over 2x minus 2. Now you say that is my answer, but does my answer simplify? We now factor it, right? So on top, you said it factors to be, you're right, x minus 2 and x plus 1, correct? Well, multiplies to be negative 2 and adds up to be 1. 1 times 2, negative 1. Okay, so it's x plus 2 and x minus 1. Everybody good with that? Then on bottom, what do we factor out? 2 left is x minus 1. So then you'd say that is my answer. I didn't say I have to exclude any values, so now I can divide out those. So my final answer would be x plus 2 over 2. So our last step was just making sure it didn't simplify. This one did. Any questions on that? Okay, so if I said to you, what's the total area of box 1 and box 2? Wouldn't we just find the area of this one, find the area of this one, and then add them together? Okay, so area of this one would be length times width, right? So x, I'm just going to focus on this piece for a minute. So area of box 1 is equal to x over 3 times x plus 2 over x. Let's simplify that. We don't have to exclude values for this. X is divide out, correct? So we have x plus 2 over 3. That is the area of box 1. Let's do the area of box 2 for a second. Ignore that. So that would be 3 over x minus 1 times 1 over 3. Okay, length times width was area, so then those simplify 1 over 1. So make sure, this is what I saw on the quiz, and it was mortifying. People said, so my answer is x minus 1. No, that's floating that to the top. 1's on top still, right? You get what I'm saying? Okay. So our area of box 2 is not just x minus 1, it's 1 over x minus 1. So now we'd say, okay, now I know the separate areas. We need to add those areas together to get the total area. So we have x plus 2 over 3 plus 1 over x minus 1. So to add these, don't we need a common denominator? So let's quickly do that. This one needs a 3, so 3 over 3. This one needs x minus 1 over x minus 1. Make sure you distribute and combine like terms before you do anything at all. So that's x squared plus 2x minus x minus 2. So that's really x squared plus x minus 2 over x minus 3 and x minus 1. Then we're adding 3 over 3 times x minus 1. So I'm showing all my work. I have a common denominator, so now I can combine like terms on top. Once again, do not, like a lot of people were going like this. They're seeing this, they're saying, oh, okay, so I need to simplify this, and then they'll refactor this. But that's not what we have. We haven't added the 3 in yet. Does everybody get what I'm saying? So combine those. So we have x squared plus x squared plus x plus 1, all over 3 and x minus 1. Okay? So now let's say, does that simplify? What multiplies to be 1 and add a times c and adds up to be 1. 1 times 1, but then 1, nope, actually, right? Yep, right? So, yes, that one doesn't. So that's our answer. Because at the top didn't factor, nothing divided out. We just had to find the individual areas and then add them. Okay. Sweet, that is the first section of the test. Okay, we're doing pretty good on time, so I feel like you'll be able to get through this test. I didn't know, like I said, I haven't given this exact test to anybody before. Okay, so Next portion of the test, the second portion of the test is on graphing and solving. So here we go. This is the first type of problem you're going to see. It's going to say in this exact order these few things. So the first thing it's asking us is state the points of discontinuity and then classify them as removable or non-removable. So remember the discontinuity points are when the bottom equals 0. Now to know if they're removable or not, we have to have it all factored out to see what things divide out, right? So let's just first factor this out. On top we'll factor out a 3, and then we have our x plus 2. Everybody good? I'm going to write f of x. It always helps to have it actually written out right because we're going to be doing some major algebra in a second. So don't skip little things like this. So we have f of x is equal to 3x plus 2. And then our bottom factor is what multiplies to be negative 10 and adds up to be negative 3. 5 times 2, negative 5. We can quick factor it. So on bottom we have x minus 5, x plus 2. So our points of discontinuity are at x equals, so x cannot equal 5, x cannot equal negative 2. So our points of discontinuity are at x equals 5. It cannot equal 5, but at 5 is our discontinuity. And at x equals negative 2. So now you have to classify them as removable or non-removable. So now let's see, do they remove or not? X minus 5, does that divide out with an x minus 5 on top? No, so it's not removable because you couldn't remove it. So non-removable. X minus 2 is our discontinuity. X plus 2 is what generated that. X plus 2 and x plus 2 divide out to become 1. So make sure you write in 1s. So that one was just removed. We literally just divided it out and removed it. So this one would be classified as removable. And that's also considered our whole. Very good. So now it says, what's the simplified expression for the rational? It would be 3 times 1, so 3 over x minus 5, correct? And let's write it correctly. So f of x is equal to that. List all the vertical asymptotes. Vertical asymptotes are the ones that don't divide out, right? So 5. You have to write x equals 5. If you just write 5, I have to mark it wrong. Well, I have to mark it half wrong, so you didn't write it correctly. State all the wholes. We have one whole. So at negative 2, comma something. Holes are at points on a graph. So we've got to now plug in negative 2 into the simplified function, correct? Because I'm saying, what is my function at negative 2? So f of negative 2, 3 over, so let's do some algebra. 3 over negative 2 minus 5 is, yep, so 3 over negative 7. So that's just a pretty way of writing it, 3 over negative 7. When we actually go to plot that, you would want the decimal value, you know what I mean? Because it's easier to plot that point and like know exactly kind of where you're looking at. So find the horizontal asymptotes. So you can use this, guys, or you can use the original, whichever one, the simplified one or the original, whichever one you want to use. So let's look at both for practice. So you look at the leading terms, but you never want to look at it factored out because that will confuse, like that will trick you. So let's look back up here at the original where it's all multiplied out. 3x divided by x squared. Does it divide evenly at all? 0 times. So our horizontal asymptote is at y. You have to write y equals 0. Let's look at the simplified one. 3 over x is 0 times. Do you see how it's the same thing? Okay, so now it says state the domain of the function. Well, the domain was these discontinuities are the only x values we can't beat. That's how you should write it. X cannot equal 5 or negative 2. Now those are 2 x values that you know for sure you will never ever beat. And it is not even going to ask you the range. Not even going to ask the range. So now it says identify the x-intercepts and y-intercepts. So remember, I personally go off to the side and make an xy chart. So x-intercepts, and I'm going to write x-intercept so I remember that that's what I found when I did something. And I'm going to write y-intercept. So the x-intercept is when y equals 0. The y-intercept is when x equals 0. Now let's check, can x equal 0, first of all? Yes, right? So we are definitely going to have a y-intercept. Okay, let's use algebra to do this. So let's do our x-intercept first, when y equals 0. You can use it on the simplified function or the original. Do you want to use the original or simplified? The simplified one's fine with me. Here we go. So we have f of x, which y is f of x. So we're doing some algebra. 0 is equal to 3 over, no, wait a minute. Let me think if I just lied to you. 3 Sorry, maybe I just lied to you a second ago by saying we could use the simplified one. No, I didn't lie to you. We could use either. So, we're going to do both just so that I don't confuse you. Okay, so 0 equals 3 over x minus 1. Oh, minus 5. Yeah, sorry, I can't remember. So now we would multiply up by x minus 5 by getting our common denominator, right? So 0 over equal 3. No, so that means that there is no x-intercept. No x-intercept. Now, what if we would have done it with the top one? We would have had, it's going to come out the same, but I want to show you. So if we would have had 0 is equal to 3x plus 6 over the bottom, which we know the bottom will always multiply to be 0. Now, if you do solve, this one does solve, but watch what happens. So you'll subtract 6. So we have negative 6 is equal to 3x divided by 3. So that's negative 2 equals x. Now, is that x value okay in our domain? No, so that's why we throw out that answer, even though we got it algebraically, because that's the one of the x values we know we'll never have. So it did come out the same. Does that make sense? Okay, sweet. So this one had no x-intercepts. So you'd write that on the x-intercepts, none. Okay, y-intercepts, there will be one, so that's when x equals 0. You can plug it into the original function or the simplified. Let's just go with the simplified. 3 over 0 minus 5 equals 3 over negative 5. So that is our point. That's just a decimal, but negative 3/5. So our y-intercept, and you would have to write it as a point. That's one thing that we were talking as teachers, and they were like, we need to write our answers for x and y-intercepts as points. So that was 0, comma, negative 3/5, and then when we go to graph that, we're going to want to make sure to write it as a decimal. Questions? I know you can do it. Okay, awesome. I thought that I had you graphing that one. Okay, no, we'll do that one. Okay, sweet. So match the graph below to the equation it represents. So the next part will be matching. Yes. Yes. So that's a quadratic and we're solving it, right? So you just solve by factoring. So then you would have two answers. Cross x axis twice. Does that make sense? Or you would look at those x values and say, are both of those actually in our domain? Are we sure that that's the bell actually ringing? Yeah. What? Okay, so then, wow. So make sure, I mean, the graphing's the same idea thing, right? That's exactly what we just went over. And then solving, get a common denominator, solve the top. Check your answers. Sorry, I should have went faster. All right, well, you should be good. We get a common denominator. Well, to know what our common denominator is, we have to have our denominators factored. This is an equal sign, so we'll be actually solving for x. So I have x over x plus 1. That didn't factor. We have plus x over x minus 1 equals 2 over, what does that factor to be? Okay, so our least common denominator is x plus 1, x minus 1. Correct? Any questions? We must have questions. Okay, so let's fix this. This one needs an x minus 1. Okay, I'm not going to talk because I already know how to do this. What should I do? Do what? So this one needs an x plus 1 over x plus 1. I need parentheses, correct? Rewrite your problem again. Okay, so now because it's a solving and we have an equal sign now, because make sure though, denominator, 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 are they all exactly the same? Okay, so now yes, we can cross out the denominators. Now on top, we're going to want to distribute x squared minus x plus x squared plus x equals 2. Now what would I do? Okay, x squared plus x squared, negative x plus x. So 2x squared equals 2. What would we do next? We're trying to solve for x. Divide by 2. Then we have x squared equals 1. Then what? Okay, square root both sides of the equation. X is equal to, we cannot forget, plus or minus. Okay. Okay, now we have to check our solutions. This is where it tends to be the hardest, guys. I'll be right with you, like 2 seconds. Let's plug in 1. Everybody watch, because I am telling you, like, you get how you solve, and then you can't do the part that is, I can't say it's the easiest part, because it tends to be the hardest. Plug in 1. So let's say like this. X equals 1 is what I'm checking. Let's plug in 1. 1 divided by 1 plus 1, correct? Plus 1 over 1 minus 1. Does that equal 2 over 1 squared minus 1? Does everybody see how I plugged it in? Let's start simplifying this. That's 1 over 2 plus 1 over 0 equals 1 over 0. Can we divide by 0 first of all? No. If you divide by 0, take your calculator. Try 1 divided by 0. Is it 0? No. It says error because your calculator is saying, what the heck are you doing? You can't divide by 0. Does everybody understand? So we would say, this is undefined. That can't happen. So x equals 1 is not in our domain. Does everybody understand? We throw that answer out. Well, let's check negative 1. Negative 1 over negative 1 plus 1 plus negative 1 over negative 1 minus 1 equals 2 over parentheses negative 1 squared minus 1. Let's check it. Negative 1 over negative 1 plus 1. 0. Oh, can't I just stop there? Okay, so we're saying that negative 1 is also not in our domain. Did we solve this correctly? Yes. So our answer would be no solution. Do we have questions? Okay.